This video provides an introduction to the Q-Skills Six Sigma module. Q-Skills is a self-paced e-learning product designed for people of any skill level from any industry. We'll start by looking at the Q-Skills menu, and from this we'll select the Introduction to Six Sigma. We'll see here that there's two means of moving through the training course. We can either go through as an unskilled user by clicking on successive pages, or we can drill down and get more information if we're a more skilled user. What we're going to do here is just click next page, and that takes us on. Six Sigma is a way of checking quality by counting defects, and this is the fundamental behind Six Sigma. Now, a defect occurs whenever a product or service goes outside of its specification, although in reality we should always try to measure variables rather than counting defects, because this gives more information about our process. However, when we can only count defects, we should plot the defects on what's known as an attribute control chart. And from an attribute control chart, if we want to, we can calculate sigma. Not that this is particularly useful, but this is the way we should calculate it. Under no circumstances should we ever use Six Sigma tables, because this will give false results. Let's just move on. Six Sigma sets a target for quality, and that target is based on a specific level of defects. And the way Six Sigma does this is by broadening specification limits so that defect levels are reduced. But this can only happen if the process is predictable. If the process is not predictable, any number of defects may occur, no matter where the specification has been set. Now, the way in which we determine whether or not a process is predictable is by using what's called a control chart. And we'll go on later in Q-Skills to learn how a control chart is used and how it does predict whether a process is predictable or not. Now, we may happen to have a process that is operating on target and producing good quality. But in reality, the target is set by what the customer wants. And if our process is not capable of achieving this, we'll produce defects. Of course, the way we monitor the process, the way we monitor the voice of the process, is using a control chart. And there's often a lot of confusion around this, but there is no such thing as a Six Sigma control chart. Control charts always use 3 sigma limits. The way we improve the process is by using the quality improvement tools, and this is the focus of Q-Skills. As we go on through Q-Skills, we'll learn what the tools are, how they interact, and we'll learn about them through a variety of games and exercises that teach us how to improve processes. Part of Six Sigma theory is that all processes drift over time by 1.5 sigma. Now, this is absolute nonsense. If such drifts do occur, defects will be produced, because the process won't be in control and it won't be predictable. If the process is not predictable, anything can happen. In reality, if processes are well managed, drifts will not occur, and you can maintain good quality. As a result, what is much more important than counting defects is to measure variation, keep the process on target, and to reduce variation. And the way we do that is by plotting data on control charts. And as I mentioned, we'll be learning more about them later. So, provided that we do maintain processes on target and we do reduce variation, we'll end up with happy customers. Counting defects was the traditional view of quality, going back 50 years or so. It was what was referred to as quality assurance. What is much more important is to keep processes on target and to reduce variation. We see what's happened here as each section is completed. We're taken up to the flashing green arrow, and we can click that and move on with the next topic.